My name is Christian. I'm part of the volunteer group at DreamHack. I'm going to tell you a bit more how this works in a while. But this I'm going to focus because we had so many awesome descriptions on technologically how to build monitoring systems. I'm going to quickly go through that on DreamHack and talk a little more about the personal, like the training aspects we had about teaching people how to use it and such. I think maybe you guys will appreciate that as well. So let's start a bit about what is DreamHack. I want to do a hands up if, let's start easily. How many here knows what a festival is? Like have heard about a festival? Okay, cool, that's great. A demo party. Oh, that's great, that's also great. A lawn party. Okay, it's kind of the same. Usually people don't know that thing. So DreamHack is what you get if you bring all these things together, right? It looks like something like this, right? Which is kind of amazing when you just look at it. It's like you have a lot of computers and a lot of switches and stuff like that, and also people having a great time listening to music, and you have like scenes and all that thing. So I really believe DreamHack is a digital festival with elements of demo coding and a lot of eSport and stuff like that, right? So professional gaming for people not familiar with the term. So this is one of the three halls of DreamHack. The picture doesn't really make it justice, but it's about maybe 6,000 people and their computers in this hall, and we have three of these halls. So you do the math there. If you look closely, you can actually see the computers and switches, which I think is hilarious. You also see like a sea of people having the mobiles because it's a festival, right? So we have about 10,000 computers, people bringing their own computers there, and we have 500 switches creating what we call the access layer. I wrote a blog post on the Prometheus blog about this, so if you want more details on how we build the network, that's covered there, or just grab me and I'll happily talk about it. DreamHack itself is a corporation. They sell tickets for this event, but the part I'm part of, I guess, the organization I'm part of is called DreamHack Crew, which is like in a lot of festivals volunteer. So we just go there, we get food, we get a place to sleep, but otherwise we just work for free just because we think this is so fun to work with the people there. We're about 500 people, and the group that is responsible for the network and power distribution is called DreamHack Tech. So I'm part of that, and it's about 50 people in DreamHack Tech. That's obviously, according to me, the coolest team, but I'm biased. So anyway, I told you already. My name is Christian. I'm part of the sub team called Services in DreamHack Tech, and yeah, if you want to reach me or you've seen me around, it's Blue CMD is my nickname. It doesn't have anything to do with my name. It's a long story, but it's actually my first gaming nickname, so now you know. Anyway, so let's actually, we're here for the monitoring, right? So let's start to talk a bit more what we came from in the networking perspective on DreamHack, and why we thought it was a good idea to change. I don't know, is anyone here familiar with the software suite SNMPC? Oh, I pity you, yeah. No, but it's a Windows application where you put out these objects on a map, and it does SNMP polling. It was the only thing we used Windows for. So that alone was reason we thought to find something better. And well, you know, we're open source geeks, right? So anyway, we also use Cacti for monitoring the network interfaces on switches and stuff. We used an IRC bot that took syslog and then spewed it out into a channel because we thought that was a reasonable way of detecting errors. It sounds fun in retrospect, but you know, we even had color codings for errors. So. We had a lot of scripts doing stuff like watching the device if the switch ports were linking in non-optimal speeds, which is, if you read the blog, something that we're actually being able to do now with Prometheus, which is much, much better. turns out that there is a limit on the number of scripts you can have on this, not because of you have servers that execute the scripts, but because of the actual switches not being able to handle being pulled by different scripts all the time, right? So they will actually stop serving traffic, which happened, kind of sad, but yeah. So DHMON, short for DreamHack Monitor, and we got tired for having this mess of different re-implementation of independent systems. So we wanted something that we could go for as a source of truth, right? So the idea of having this centralized monitoring solution came out of the motto which we used quite a lot in the beginning, was like, because we can do better. And yeah, so it was fueled by that. So the objectives were simple enough: monitor everything and be able to alert when things go wrong, right? So I'm gonna go quickly through these. So the first iteration was, we didn't want to write so much code. We thought that like, oh, sorry, I forgot to tell you this. This is quite essential. When we arrive at DreamHack, it's an empty hall, like nothing there, right? And we have 7 days to build this, which means that we have no technical legacy. We can do whatever we want, but we need to have it working after 7 days, which means that iterations is important to us, but so is, having something that actually works at the end of this building session. So the first way we were doing this, we were kind of scared of ending up with nothing working. So we tried to rebuild by parts that were out there. And this was 2014, DreamHack summer 2014, which was before Prometheus was released, right? I think it was January, right? 2015, yeah. So we started using Sensu, Graphite, RTG, which is like the C SNMP polar, and Cassandra for a backend for that. And it turns out, even though you're using reliable pieces, tying them together isn't that reliable always. So it was kind of, it worked. We had some graphs, but it was horribly slow, and it was, yeah, we kind of went away from that. And for the winter, we tried actually using a software called InfluxDB. It was one of the earliest releases, so it did work much better than our previous solution, but it was very, very early in InfluxDB's lifetime, or software lifecycle. They didn't really do, reliability in the software as at that point, so we lost quite a lot of data, which kind of is a bad thing, right, for a database. But so we also had, it was 0.2. Like, I'm sure it's a hard problem, right? But we got pretty sad at that point for that. But so we used Memcache and Redis as well to collect like the closest layer of data we needed, mostly because at that point also we weren't knowledgeable enough to at least to configure Influx to be as fast as we wanted. We have this SLO that we should be out on our way to fix a switch if a switch is down in the network before the customer is actually able to go to support to report it as being down, right? Which means we have about 15 seconds to detect a switch failure and be on our way to go there. So InfluxDB was, we couldn't be able to do our queries at that rate for InfluxDB, so we used a Memcache layer for that. We also built this as an MP collector, which made, which looked at all the devices in the network, provided a view, and shoved it into InfluxDB and Memcache and Redis. So in that kind of worked, but with the fuel of the InfluxDB incident or whatever, we didn't want to redo this. And at this point, Prometheus had been released, and we were super excited about using it. We weren't. I think we insulted the core Prometheus developers in a way, because we didn't really believe it could handle the 15-second SLO with ingestion of ICMP or ping keep alives. So we kept the Memcache in front of this. Turns out that we were wrong, and we got a challenge for the next DreamHack to skip that, and it works just perfect. So we're really happy with this general thing. We went from like this a lot of distributed systems into just Prometheus, but our SNMP collector. which was, as Brian said, it was before the SNMP exporter existed. We do some crazy stuff in our SNMP collector. I'm happy to tell you more about it outside of this talk, but other than that, this was the winning concept that we really focused on. So today, it looks basically the same, but this last event, which was just a few months ago, we started using alerts, which is it's a crazy thing, right? It's like we're using alerts, but it's like if you remember where we were, like in 7 days we have to build a network that works. We're kind of just looking at graphs at the last few days just to make sure that that's our alerting. Someone looks at the graph and it looks wrong. So having alerts now is a big, huge step forward for us, or actually being able to have the time to manage this system. And I think that's actually a very good point for Prometheus, is that it's so architecturally simple that we don't need a Cassandra database, right? We can just install it, have our configuration management generate the config, and then we're done, basically, right? We spend a lot of time writing collectors, though. And you know, that shards easily. We can just teach, 5 people to write collectors and tell them go collect things, and that works, right? Oh, sorry, exporters. I should call them exporters. But yeah, so this was the latest. I just extracted this from our Prometheus instance from last event, and we're running at 553,891 metrics. The users doesn't really matter, but it's fun. It's a fun number, right? It's more than 500 switches, which would be a less number to have here, but it's So 500. It's more than 50,000 people that care that the network is running, if I put it that way. But yeah. So this is my favorite part. This is the one I kind of get on time. So what didn't work as we expected here, right? There's a lot of things. Did anyone here? I know some people here went to Monotrama. Hands up if you went to Monotrama. It's a great conference. It's if you happen to be in the States there. And it's time-wise. It doesn't collide with PromCon either, so you can go on both, right? So, but they spent like half the conference talking about the human aspects of alert fatigue and all that stuff, which I think while we rushed through this, we already have a stressful environment, and now we're adding new technology to this for people used to run cacti and SNMPC and stuff like that, right? How did that transition work for us, right? So that said, I'm actually going to start with the technical challenges just so we get those over with. So again, I actually wrote this before Julia's talk about why they chose to not have a clustering, right? But clustering is hard, and I actually had to look this up as well to be sure that this wasn't just something I dreamt of, but apparently people think, and I agree with this, the first law of distributed object design is don't distribute your objects, right? So yeah, clustering is hard. Let's not do clustering if we don't need to. Like Prometheus, we have one Prometheus server in the whole DreamHack with these 500,000 metrics, and it barely breaks a sweat. And what's more is like, I just have to say, as an operator, it's a great product to have. You look at your CPU utilization, it's just basically super aligned on all the CPUs, which is like, oh, that's so beautiful. It's not like one CPU is being pinned or anything. So, and also sharding is usually easy, right? You have this service discovery. It contains 500 switches. You shard on the first letter of the switch name or whatever, right? If that is uniform. Yeah, and just because Hacker News says it's awesome, don't trust that you can build it into production quality in 7 days. There are some awesome projects on Hacker News, but yeah, that does not mean that they're ready for production. I wish I knew that before, but now you know. Keep it simple applies more now than ever in this weird clustered network, cloud, convergence, all those buzzword world, right? So if you and again, I really believe that Prometheus solves all this in the right ways here. Oh, sorry. Okay. So to move on to the people part here is change is hard. The way the network team or the tech team in DreamHack is built up is part of subgroups, right? I was part of the services group, which basically means our job, if you so will, is to build solutions that run on Linux servers. This is like building monitoring solutions is part of our job description, right? But we have other teams that have their job is to build the pairing with the ISPs that we have, or the access layers or the Wi-Fi layers. While changing everything like this, how do you make sure that you don't trample on people's toes here? How do you make sure that they are involved in a way that makes them feel appreciated and actually excited about this, so it doesn't become, oh, they're changing this system again, right? So, yeah. If I do have this example that happened during when we were switching to Prometheus was, one of the network team said, I'm having this network issue here. I think we're having a loop in the network during the build-up. I want to see the interface graph of this interface and this interface, and I don't like, and this is the kicker, right? I don't want to learn a new query language. Like it was like he saw on my face that you have to learn PromCon, right? But no, that is, and I can't really blame them, right? Or people in general for, they have the, one has this mission you are on, and now the whole system changed. And you're not really in a position right now to relearn that, right? So one of the things we attacked on this was to make it super simple for people to experiment, and also to have a lot of templates, right? So we created these very simple templated dashboards. Thanks for the Grafana guys for making that awesome, by the way. So we have this very simple TXRX interface, like one graph console, right? That is templated, that people can cargo call. Just copy that and change whatever they're looking at. And the funny thing that happens here is that thanks, Brian. The only thing, the thing that happens there is people start surprising you because they start to get a safe space to experiment with this. So they just duplicate this, and it doesn't matter if it breaks, right? No one cares. It's not in production yet, and they can say like, I made that graph, right? And suddenly this change becomes fun because they're part of it. And yeah, we applied this to alerts as well. We have pre-submits that do checks as far as we can, really. And people, I woke up one day and I actually found 2 new alerts that I didn't create, which was who created these, what's happening, and this is awesome, right? Because I wasn't. Because normally I was the one pushing these things and pushing new technologies to people, and now they were embracing it. Right? So, yeah, be amazed on if you give people the possibility of experimenting on this. So, the future, the open problems we have on this, right? We're nowhere near where our vision goes, right? This is the problem with playing with awesome stuff, is that you keep moving your vision forward, right? You see like, oh, but we can do this and that and blah, blah, blah. So let's talk a bit more about what data sources we have in DreamHack and what we're trying to make out of this, right? So 99% of the data we have today is SNMP poll data, the other being ICMP and some service statistics like disk space and stuff. So of the data we use, 99% is polled by SNMP. I mean, that's nice. It works for the usual case, but we also have stuff, and this may not be a Prometheus problem, I don't know. But it's stuff like we're just beginning to explore right now is the net flow. We have a huge amount of net flow, right? We have 15,000 people communicating in a network. What are they doing? How can we make this into time series in a way? Can we make it so that we know, for example, which kind of traffic inside of the network is the most common? Probably. I don't know how though yet. We haven't started. Yes, there is. Okay, some person agrees with me here. So if you like this, do talk to me. I'd love to explore this more. And NetFlow, by the way, is what people are doing inside the network. You probably figured out from my description, but it's high cardinality, right? IP to IP, just that is huge. We don't do any event processing. That's not Prometheus' cup of tea, but we probably have stuff that we could alert on, like if something has a lot of error rates in some syslog or something like that, right? We don't do anything of that today. So there are things we can certainly work on. Oh, other questions we're trying to figure out how to do in a DreamHack way is redundancy. Do we just put 2x of everything? Can we put 2x of some things? Can we, yeah, what's up, right? Naming, we had a discussion internally on how to name our pre-computes. Is this super long name really the best name we can have for this thing that has all the interfaces but not the high-speed ones? What should be a label? We used to have a ton of debugging stuff in labels. That resulted in that we had to do a lot of group by unless or whatever that is called, or without, and they just messed up the queries. So we sacrificed debuggability for readability. So yeah, maybe we could have something like verbosity labels or like annotation or whatever, I don't know. Open problems for stuff that, or feature requests or whatever you want to call them is, we have some appliances that we use in DreamHack that have pre-sampled data, which means that we need to send over to Prometheus the timestamp. And currently that's kind of a pain in the client libraries, so we had to re-implement that. I'm being told it's work in progress, so I'm really looking forward to that. Also, I said earlier with this being safe space, I really love to, if we can figure out a way to do unit testing for alerts. If anyone is doing this, please talk to me. Oh, one person is. I'd love to know, like, you know, having some kind of fake input set saying for this alert should fire, for some other it shouldn't, and then you just make it easy for people to spot regressions before actually committing into Prometheus or paging the whole team, right? And also the distribution visualizations, people that have been talking to me know that I really love this. So I think we should be able to work on histograms and making people really passionate about histograms. Yeah, maybe I'm weird in that, I don't know. Prom consoles used to work in PromDash. It was very useful. It doesn't really in Graphite right now. And yeah, we're kind of working around that. Graphs, right? So this is one of the graphs. This is our overview. I'm going to reward you now with some graphs. So this is our overview dashboard for DreamHack. It has stuff like, this is one of the appliances I was talking about that does traffic categorization, really cool thing, but it pre-samples data. So we had to do some hacks around that. And then, I don't know, pie charts, because why not? And then, yeah. And then this is the breakdown template stuff that I created the one up to the yeah, that one. And then other people just added more stuff, which is awesome. We try to keep everything open source. Check this out. We're a volunteer organization, so if you want to, talk to me and I'll make sure that you're hooked up with the stuff, and maybe you can join us in the networking team. Thanks to DreamHack Tech for being awesome. Prometheus Tech for building this. Grafana for disguising ugly data in nice graphs. Coverage for photos, and Slides Carnival for the presentation template. Well.
So, questions?
Not so much a question, but I've actually been putting quite a lot of thought into a NetFlow exporter.
Cool.
That would take it, yeah, take in NetFlows and do aggregations based on different configurations, geo, IP.
That's great. Yeah.
Things like that.
Love to talk to you later about that.
I am aware of a company who is actively building a NetFlow exporter at high volume.
Oh, interesting.
Yeah, and
Cool.
who plan on open sourcing it.
Right. Yeah. Oh, nice. Yeah.
You have to go the way through the SNMP exporter or collector, whatever you call it. And I can imagine that all your network devices are sponsored probably by a company with C in the name.
It's Cisco mainly, yes. It's on the access layer. DreamHack actually owns 500 Cisco switches. So, but you know, we are mostly sponsored by companies wanting to give out or not give out, but loan us equipment, right? So, if there is any company out there that wants to give us 800 switches for loan during this, we're very much interested in trying it out, blogging about it, and stuff like that. So but yeah, it's legacy, right?
Well, my question was more like if you have been in contact with them, perhaps, if instead of going the SNMP way, they would present the metrics in the Prometheus way.
Yeah, it's
you can scrap them directly.
I'm actually working on that as well. I'm working on a product called OpenSwitch. That's just a hobby, and that is actually running Node Explorer now natively. Just because I think I do agree with you. I just think it's a sad state of the world that SNMP is the best we have, but I don't think we can solve it in any nice way.
Another question, just a small comment. When you were saying that you were interested in looking at errors in syslog and whatnot, maybe you should look into MTail. MTail. MTail lets you process logs with regexes and create metrics out of that.
Yeah, we should definitely look
into it. A Google product.
This is just stuff we haven't started looking into yet because we've been focused on the time series, like yeah. So definitely, thanks a lot.
Someone also released a Grok exporter, which is the same idea in the last few weeks as well, was on the list.
Cool.
All right, there's lightning talk about the Grok exporter, right? So the guys here. Okay, any other questions? Yep.
I was interested to hear a little bit more about how you're putting in the sample data.
So yeah, it's super easy actually. So in the Prometheus format, you can just append the time series that the data is for. So basically, we make sure that we sample it. That we call. We created our own Prometheus client that just adds this extra part on a timestamp on the end. That is the actual timestamp for the data, and then we just make sure that Prometheus is scraping that target at least once actual sample period. It's not nice, but it works for us, right? Otherwise, we have these weird aliasing artifacts which really screw up graphs and stuff. So
I think that's it. So thank you very much.
Thank you.